Hello everyone and welcome to another short video on solving a LeetCode problem with APL. And I have to start by apologizing because the idea of these videos, at least for me, is to solve these problems for the first time in APL with you, and hopefully that shows you a little bit of how thinking in APL might look like. And for the first recording I did while solving this problem, I actually ended up with a video that was way too long. And that's just because the structure of this problem is fairly different from the other little problems we have been doing. And it's not to say that this is a difficult problem, it's just that the structure of the things they want us to do is very, very different. So we've been solving some algorithmic problems, and this is more of a problem where you have to structure a small program. And this actually makes it a really interesting toy example for how namespaces and classes work in APL. So I'm going to take this opportunity and show you a little bit of that. And so, yes, the full disclosure, I have read this problem and I solved it just 10 minutes ago when I was recording. And so this is a re-recording, which hopefully is going to be a lot cleaner and clearer as well. So the problem statement says that they want us to design a parking system. And this parking system has or keeps track of three types of parking spots. There's parking spots for big cars, parking spots for medium cars, and parking spots for small cars. And the idea is that a car can only park in a spot that corresponds to its specific size. So a medium car can only park in medium parking spots. It cannot park in bigger parking spots nor in smaller parking spots. So the idea is that we need to implement a function that initializes, that creates some parking system that is able to keep track of these parking spots. And then there's another function, which is the addCar function, that takes a type of car, which corresponds to big, medium, or small cars, and it tells me true if I was able to park the car or false if I was not. And what is more, the parking system should update itself and say that or reduce the count of available spots. And they have an example here. So they are creating a new parking system with one spot for a big car, one spot for a medium car, and 0 spots for small cars. And so the first time we had a big car, it gives true because it was able to park that car. And then we had a medium car and it also returns true because we were able to park that car. But then it adds a small car and it fails because there were no spots for small cars. And then we have another big car and this time it fails because the only parking spot we have was occupied by the very first big car. And so we are going to tackle this problem in 3 different ways. This is a really simple problem, and so they do ask for a solution with object-oriented programming. But we will start, in this video, we will do something which is simpler, and we will just keep track of the state in a simple vector with the parking spots. And then I will link in the description to 2 other short videos. One of them we solve this problem with namespaces, and in the other one we use actual object-oriented programming in APL, which is something APL can also do. So yes, on to the very first solution. So the way we are going to do this is, well, first I should open an interpreter so that we can work with it. Wait, sorry, wrong thing, give me a second. Okay. So we start with nothing, and the idea here is that our parking system, which won't be a class right now, it's just going to be a vector, is going to be composed of these numbers. So it's a 3-element vector with a number of spots for each type of car. So actually our function that initializes a parking system is a function that does nothing, because if we want to initialize the system with these spots, then what we want is to actually get that vector. So this is our function to quote-unquote initialize the parking system. It's the right tag which takes this argument and returns it unchanged. And now what we need is a function addCar that will take the parking system on the left. So let me save this parking system. It's PS for parking system. And now we take the parking system and we give it as a left argument to the function addCar. And in here we say the type of car that we want to add. And it doesn't work because I haven't defined the function. And the idea here is that when I add this type of car to this parking system, then the function returns the new parking system, changed the new value, and returns the boolean saying if it worked or not. And the way we could do this is by doing a multiple assignment. So we can unpack the result by saying something beeped on my computer. It's because I have it open, sorry for that. So the idea is when we call the function like this, we actually assign the result like that. Okay, and this will be the new parking system, the new updated state, and this is the boolean that says if it worked or not. And so we need to define this function. And how can we go about doing that? Well, there's two things we need to figure out. We need to figure out if we can park the car or not, and we need to return the new value. And if this were some classical programming language that you are, some of those mainstream programming languages, or a not array-oriented one, you would probably use an if statement. But let's not do that. Let's write this in an array-oriented way, or an attempt at that. And so the first thing we are going to do is to take the car type and produce a Boolean vector with a 1 in the place where that car will go. So for a car type of 2, we would create this. And this says, to park this car, our parking system needs to have 0 big spots, it needs to have 1 medium spot, and it needs to have 0 small spots. Or if we were adding a small car, we would generate this Boolean vector, because it says, okay, my parking spot doesn't need any big or medium spots, but it needs a small spot. Then we can take this and we can try to subtract it from the actual parking system. And in this case, well, there's no spots for small cars, and so when I subtract this 1 from this 0, what happens is my parking system suddenly gets a negative value. And that's something I can't have. My parking system cannot have a negative number of spots available. And with that I can see if I can park that car or not. Because doing the parking system minus this little vector over here gives me negative values. And then I just need to be able to pick the correct parking system, which is either the original one if I cannot park the car, or the new one if I can park the car. And as you'll see, this is fairly simple to do. So let me go ahead and open my editor to implement this function that adds the car. And this is it will be a short different. So the first thing we do is we try to create the new parking system, and that should be the old one, which is the left argument, minus that vector we just described. So it was something like, can I delete this line? Yes, delete this line. So I have this, and then I wanted to, for this type of car, I wanted to create this vector over here. So what I'm going to do is I'm going to use iota 3 to create 3 integers, and now I see that to toggle or to turn on, let's say that to turn on the first, to turn on the middle element there with the 2, what I need to do is add 1 to this and then compare with my car type. So this works for a car type of 2. So if I wanted to park a small car, then the car type would be 3. And if I wanted to park a big car, my car type would be 1. So this creates the vector that I need, and this is the car type. So the car type here will be the right argument, and I need to compare it with this vector. So this gives me the new parking space. And then I need to return the new parking space and the Boolean value. And the Boolean value should be 0 if there's a negative value in here, in this new parking space. So if there's a -1 in the new parking space, then this gives me 1, and in that case I actually want to return 0, so I need to use the tilde to negate this. Otherwise, if there's no -1, then this gives me 0, but I actually want to say that I was able to park the car, and the negate turns that into a 1. Now what I need to do is, should I return the new parking space or the old one? So which one should I return? And the thing here is, if the new parking space does not have negative values, then I can just return it. But if it does have a negative value, if it has a -1 there, then I need to revert that, and I need to revert that -1 to a 0. So what I can actually do is type something like new parking space max 0. Because if all spots are fine, then this does nothing, and if one of the spots became negative, then this will reset it back to 0. So I can actually do this. Now let's press escape to fix the function, and now I can use the function, and you can see how it works. So let's go ahead and create the parking system that's used in the example, and let's do the following. Let's take the parking space, and to this parking space let's add a car of type 1. And I was able to park that car, and now these are the spaces I have left. Now let's do the same thing again, but now let's park a car of type 2. Was I able to park it? Yes, I was. How many parking spots do I have left? Oh, 0 for each type. So now let's try to park a car of type 3. And let me press, I think it's Shift Enter. No, it's not. Control Enter, so we can trace through the function as we go along. So we just enter the function. This is the line that we are going to run now. If you take a look here, omega is the 3 there, alpha is the parking system, and so I can run this line, and now I see that the new parking system is this thing over here. So what's the Boolean value here? Well, let me copy this and paste it here. Well, this is 0. Why? Because there's a -1 in there, and when I negate it, it becomes a 0. Now, what is this? If the new parking system has a -1 here, when I max it out with 0, then that -1 becomes a 0. And this is basically me resetting the new parking system to what it was before. It was 0, 0, 0, then new parking system is 0, 0, -1, and then if I max it out with 0, it resets. And this would have worked if I had other available spots in here, because if I have other available spots in here, these would be positive, and so maxing them with 0 would do nothing, because those other values would be greater. So I can also run this, and then we leave the function. And we see that I did not park the car, and the parking system stays like that. And so just to show you this one more time, I have available spots for big and medium cars, but if I try to park a small car, so let's take the parking system and add a car of type 3, notice that the parking system remains the same, and the boolean is false because I was not able to park this car. And so this is the solution without any fancy types of structures, without namespaces, without classes, etc. Just us keeping track of the state in this vector. And if you have another simple alternative, well, feel free to leave them in the comments below. Otherwise, if you want to see how this could be solved with, or in a more structured way, with a namespace or with a class, there's going to be 2 videos linked in the description. And if not, then I will see you in the next video. Well, bye.